Right now, as you watch this, a spacecraft is falling through darkness. No stars ahead of it. No planets. No landmarks of any kind. Just an endless, freezing void. Temperatures close to absolute zero. And it has been falling for over 47 years. It launched before the internet existed, before personal computers, before most of the people watching this were born. And it is dying. Not in a dramatic explosion, not in a collision. It is dying the way a fire dies, slowly, quietly, running out of fuel. And here is the part that makes engineers lose sleep. We cannot go get it. We cannot send a rescue mission. We cannot even send a software patch in time to matter. This is Voyager 2. And these are its final days. Let us start with distance, because until you truly feel this number, nothing else makes sense. Right now, Voyager 2 is approximately 12.8 billion miles from Earth. Say that again? 12.8 billion miles. If you drove a car at highway speed, 65 miles an hour, no stops, no sleep, it would take you roughly 21,000 years to reach it. But here is the number that really breaks your brain. When NASA engineers in Pasadena, California send a command to Voyager 2, that signal travels at the speed of light, the absolute speed limit of the universe. And it still takes 18.5 hours to arrive. One way. So a conversation with Voyager 2 takes 37 hours round trip. Not because anyone is being slow, because physics itself will not allow anything faster. If this is making your brain hurt in the best possible way, smash that like button. It helps this reach people who have never thought about this before. That is not a communication problem. That is a fundamental law of the cosmos. And Voyager 2 is still going. Right now, it is moving at roughly 34,000 miles per hour, faster than any bullet ever fired, and it is still getting farther away. It crossed into interstellar space in 2018. True interstellar space. Beyond the heliosphere, the protective magnetic bubble our sun blows around the solar system. Voyager 2 punched through that boundary and entered the territory between the stars. Humanity has done this exactly twice in history. Voyager 1 first in 2012, Voyager 2 second in 2018. No other human-made object has ever gone this far. So what is actually killing it? The answer is elegant and brutal. Plutonium. Voyager 2 runs on something called a radioisotope thermoelectric generator, an RTG. There is no solar panel far enough out to catch sunlight. Instead, a chunk of plutonium-238 decays radioactively, generating heat, and that heat is converted into electricity. Simple, reliable, no moving parts. But plutonium-238 has a half-life of about 87 years. That means every year, the power output drops, slowly, relentlessly, by roughly 4 watts. When Voyager 2 launched in 1977, its RTG produced about 470 watts of electricity, enough to power a few light bulbs. By now, it is down to roughly 160 watts. Less than your kitchen microwave on low. And it keeps dropping. Engineers at NASA's Jet Propulsion Laboratory have been making agonizing decisions for years, turning off heaters, shutting down instruments one by one, like a hospital conserving generator power during a blackout. In 2019, they had to turn off one instrument entirely, just to keep the others alive. In 2023, a software error briefly caused Voyager 1 to transmit unintelligible data for months. A near-death scare that took engineers almost a year to fix, using 45-year-old documentation. Seriously, if you find this kind of behind-the-scenes engineering drama fascinating, subscribe. This channel goes deep on exactly this stuff every week. Each decision is a trade-off. Save power here, lose science there, and with a 37-hour communication delay, there is no real-time troubleshooting. Every command is a bet placed nearly 2 days in advance. By 2020, the engineering team had developed a plan, a careful, methodical power conservation strategy. They had mapped out which instruments to shut down, and in what order. They had calculated that If everything went according to plan, they could keep at least one science instrument operational until roughly 2025 or 2026. Crisis managed. Situation under control. That is not what happened. In November 2023, Voyager 1, Voyager 2's twin, started sending back gibberish, corrupted data, nonsensical readings, signals that looked like nothing the engineers had seen in 46 years of operation. For 5 months, the team essentially had no idea what Voyager 1 was saying. It turned out, one memory chip, a single chip in the flight data system, a chip designed and built in the early 1970s, had failed. And because of the communication delay, diagnosing it, finding a workaround and uploading new software took until April 2024 to resolve. 1. Chip. Now imagine that happening to Voyager 2. Or imagine a problem that cannot be fixed with a software patch. A hardware failure, a thruster malfunction, a thermal issue caused by a heater being shut off to save power. The margin for error is essentially zero, and it is shrinking every single year. Here is where things get specific and sobering. NASA's current estimate is that Voyager 2's last science instrument will go dark sometime between 2025 and 2030. Not because the spacecraft will be destroyed, not because it will crash into anything. It will simply run out of electricity to power its instruments, its radio transmitter, and its ability to orient itself toward Earth. When the power drops below a certain threshold, the transmitter dies. And when the transmitter dies, silence. After that, Voyager 2 will continue moving. For billions of years, in roughly 296,000 years, it will pass within about 4.3 light years of Sirius, the brightest star in our night sky. It will outlast every mountain on Earth. It will outlast the Sun itself, which will expand into a red giant and swallow the inner planets in about 5 billion years. But we will never hear from it again. If you want to see more videos about the spacecraft, missions and discoveries that define our species' reach into space, share this video. It only takes 2 seconds, and it means everything for this kind of content to survive on this platform. Here is the thing that keeps me awake at night, and I mean this not with dread, but with something closer to wonder. Voyager 2 carries a golden record. A gold-plated copper disc containing 116 images of Earth, greetings in 55 languages, music from Bach to Chuck Berry, the sound of rain, the sound of a mother's first words to a newborn child. It was placed there by a team of scientists, led by Carl Sagan, who understood that they were building something that might outlast everything humanity has ever made. Every book, every building, every recorded piece of history. They were creating a message in a bottle, thrown not into an ocean, but into the cosmos itself. And now, as Voyager 2 spends its final operational years transmitting its last faint data back to us, readings about the plasma density of interstellar space, magnetic field measurements from a place no human instrument has ever sampled before, I think about the sheer audacity of that original launch. They did not know if it would work. They did not know it would survive 47 years. They built it with technology less sophisticated than a modern digital wristwatch, pointed it at the outer planets, and let it go. And it worked. We are not losing Voyager 2. Not really. We are releasing it. After nearly 5 decades of faithful service, we are finally letting it do what it was always destined to do, become the farthest traveling artifact of human civilization, carrying our music and our voices and our images into the dark between the stars. Long after our cities are dust, long after our sun has gone cold, long after anything that knows the word humanity has ceased to exist, Voyager 2 will still be out there, still moving, still carrying that golden record, still, in some profound sense, us. And that, to me, is not a tragedy. That is the most human thing we have ever done. If this video made you think differently about where we are in the universe, drop a comment below. Tell me, does knowing Voyager 2 will outlast our entire civilization make you feel small? Or does it make you feel proud? I read every single comment.